In the first video on the effects of a specific tax, we learned that the incidence of tax does not depend on who the government imposes the tax on. What the incidence of tax does depend on is the elasticity of supply and the elasticity of demand. We showed graphically that the incidence of tax falls more heavily on the less elastic party. In this video, we are going to apply what we learned to supply and demand equations, and then to elasticity coefficients. Consider the following problem. In a competitive labor market for unskilled workers, the supply of labor is given by this equation, Q equals 20 plus 6W, and the demand of labor is given by Q equals 260 minus 18W, where W is the market wage and Q is the number of workers in thousands. It is important to note that the demand curve describes the quantity of workers demanded by the employers, and the supply curve describes the quantity of labor supplied by the workers. In the labor market, it is the employers that buy the labor and the workers that supply the labor. Please take a minute and solve for the competitive market equilibrium wage and employment. Setting the quantity of labor supplied equal to the quantity of labor demanded and solving, we get a wage of $10 and employment of $80,000. Now let's add a tax to the problem. If the government imposes a $4 specific tax, what would be the wage employers pay, the wage workers receive, and the employment? To solve this problem, we need to take into account the fact that there is a $4 tax. The wage that the employer pays will be $4 more than the after-tax wage the worker receives. This is described by the tax wedge equation here. It shows that the wage the employer pays, WD, has to cover the wage that the worker receives plus the tax. So in the supply and demand equations, we now include subscripts so that the wage the employer pays, or WD, and the wage the worker receives, or WS, are different. When we set quantity supplied equal to quantity demanded, we have three equations and three unknowns. The three unknowns are equilibrium quantity, the wage employers pay, and the wage workers receive. You will solve these three equations for the three unknowns similar to the way that you have solved the equilibrium price and quantity with just two equations. Please take a minute and solve for WS, the after-tax wage that workers receive. To solve for the wage workers receive, we start off setting quantity supplied equal to quantity demanded. The problem now is that WS and WD are different. If we substitute equation 1 into equation 5 for WD, we get equation 6, which has both equations written in terms of WS. This enables us to combine terms. So when solving the three equations for the three unknowns in the tax problem, we can substitute the tax wedge equation for WD so that we can combine terms and solve for WS. Doing this, we get that the wage that workers receive is $7. Now let's solve for WD, the after-tax wage that employers pay. To find the wage that employers pay, substitute WS into the tax wage equation. We find that the employer pays $11. $4 of this goes to the tax, and $7 will go to the worker. To find the quantity of labor, we can substitute WS into the supply equation or substitute WD into the demand equation. Either way, we get 62,000 workers employed. This is a graphical representation of what we have done. The $4 per unit tax causes the wage that the employer pays to increase by $1. So employers are paying 25% of the tax. The wage that workers received fell by $3. Thus, 75% of the $4 tax is paid by workers. Often in real-world applications, we have estimates of the elasticity of supply and the elasticity of demand. The pass-through equation given here gives the fraction of the tax paid by the consumer as a function of the elasticity of supply and the elasticity of demand. If we are applying this to a labor market, then the pass-through fraction gives us the fraction of the tax paid by the employer. Let's apply the pass-through fraction to the problem we have been working. First, we need to calculate the elasticity of supply and the elasticity of demand at the competitive market wage and equilibrium quantity of employment. What is the elasticity of labor supply? To find the elasticity of labor supply, substitute the slope coefficient of 6 in for the change in Q over the change in W. Also substitute the competitive equilibrium wage and quantity into the equation. We get an elasticity of labor supply of 0.75. Here we can see that the elasticity of labor supply is relatively inelastic because the coefficient is less than 1. What is the elasticity of labor demand? Substituting in for the slope coefficient and the equilibrium wage and quantity, we get an elasticity of labor demand of negative 2.25. So the labor demand is elastic. Now we will take the elasticity of supply and the elasticity of demand that we solved for and use them in the pass-through fraction to get the fraction of the tax paid by the employer. What is the fraction of the tax paid by employers? Plugging the elasticity of labor supply and the elasticity of labor demand into the pass-through fraction, we get that 25% of the tax will be paid by the employer. This implies that workers will pay 75% of the tax. Notice that this is what we found before when we solved the system of equations. This also is consistent with what we learned in the previous video. We learned that the majority of the tax is borne by the least elastic party, regardless of who the tax is charged to. Here the worker's labor supply is less elastic than the employer's labor demand, so the workers bear the majority of the tax burden. FICA payroll tax requires employees to pay 7.65% of their earnings. Employers are required to match, so FICA tax is 15.3%. Is the tax burden really a 50-50 split between employees and employers? Does it matter that the government imposes half the tax on employers and half the tax on workers? No. Remember, the incidence of tax does not depend on who the government charges the tax to. The workers' after-tax wage will be the same regardless if the entire tax was charged to workers, or if the entire tax was charged to employers, or if they split it 50-50. How the incidence of tax is divided between employers and workers depends on the elasticity of supply and the elasticity of demand for labor. Estimates of long-run elasticity of labor demand are around -1, or unit elastic. Estimates of labor supply are very inelastic. This implies that workers are not very responsive to a change in the market wage. If the wage that all employers are paying drops, many workers will not cut back their hours of work because they have no other choices. Assume elasticity of labor supply is perfectly inelastic, which is actually realistic. This is an ad valorem tax, but the pass-through fraction still applies. What is the fraction of the tax paid by the employer? If labor supply is perfectly inelastic, the elasticity of labor supply is 0. Plugging in the values for the elasticity of labor supply and the elasticity of labor demand, we get that employers pay 0% of the payroll tax. This means that workers pay the entire payroll tax. So when you look at how much is deducted from your paycheck for Social Security and Medicare, which is the FICA payroll tax, remember that your employer is matching this amount. And since the elasticity of labor supply is inelastic, it is very possible that the wage you are paid has been decreased by the entire amount of the tax paid by the employer. So you pay 50% of the tax directly, and you pay the employer's 50% in the form of a wage decrease. It is the elasticities that determine the incidence of tax, not who the government imposes the tax on. Let's work one more problem for practice. Suppose that the demand curve for alfalfa is Q equals 50 minus 1/2 P, and the supply curve is Q equals 2P. The government imposes a specific tax of $5 per unit on producers. Calculate the price that consumers pay, the price that producers receive, the equilibrium quantity of alfalfa, and the total tax revenue. What is the total tax revenue? The first equation is the tax wedge equation. It shows that since there is a $5 tax, consumers pay $5 more than producers receive. Equation 2 is the supply equation, and equation 3 is the demand equation. We are interested in finding the price consumers pay and the price producers receive that will put the market in equilibrium where quantity supplied equals quantity demanded. So we set quantity supplied equal to quantity demanded, and in equation 6, we substitute the tax wedge for PD. Solving for PS, we find that producers will receive $19. This implies that consumers will pay $24. The quantity supplied and quantity demanded is 38. Since 38 units are taxed at $5 each, the total tax revenue is $190.